I'm speaking. Look there. I'm speaking. Okay. Okay. Hi guys. Welcome to the Java Essentials tutorial. So my name is Idar, and I'll just be giving you guys a brief overview of. I see that Carl Gladwell. So yeah, I'm joined here with Jody and Nkosi, and I think we'll just be getting right to it then. Okay, so we're starting with. Okay, so on the agenda today is we're going to start with intro and that would be setup and environment. But I think actually for now we can actually skip that because I think most people already have the environment set up, and even if you don't, you can sort of follow along with me on REPL. So I'll be using REPL as our dev environment today. So I'll just open a REPL for Java, right? That's the one. There we go. The screen. Right. So, yes. I was pretty sure it's on here. Look here. It's okay. So yeah, I'll name this Java Essentials, and after the sort of how can I say tutorial, I'll just share this REPL link with you guys. So yeah, right away, we can already get started. So I'll just remove this boilerplate code. Oh, you guys can't see my. So okay, let's see. You can only see the agenda page, right? So my screen sharing is not working, so just hold on a sec. Yeah. Okay, guys. Sorry for that. I was just figuring out this controls, but yeah, I think I just want to go briefly through the agenda of today. I'll skip the setup and environment since most people already have that set up. And on the agenda today is going to be types. I'll speak a bit about scope and access, and then I'll do also a dive into control structures and methods, a little bit of file I/O, and then after that, after the demo, no, after that, that would be questions, right? So then I'll just be assuming that you guys know Python level 1 or sort of have already an introduction to Python, and sort of the goal of this is just to get you guys going with Java because yeah, a lot of people find it difficult, and just want to show you guys that it's pretty much not that difficult, right? So right, let's get started then. So what you would do is you would create a file, like in this case, it's just in a file called main.java. And then, yeah, so the first thing that you do for any Java project, or like file that you're starting is to get a class, right? And I'll start with giving it public. I'll explain this also later. So public class, and you have to name the class the same name as the file name, right? So main in our case, and just give it the curly braces, right? And I'll explain also a bit more of the curly braces later. But yeah, this is basically almost, you can think of it for now as our container for the project, or for the file that we'll be working in. Uh, the class also has like a lot of other functionality as well, in terms of like object-oriented programming, but we won't be diving into that today. So for now, you can just assume that this is like mandatory container, right? And also, besides the class, is also the main method that you need. Just add comments also. So this is the main method, and the main method like always follows the same syntax. Starts out with public again. So this part here, with public, it's called an access modifier, and I'll also be speaking about that a little bit later. But it's basically saying that this is accessible throughout. How can I say? If you had like other files also, it would sort of be able to access it. But yeah, so public static. Static is another, you can think of it as an access modifier. But our goal here is to have a main method, and the main method is basically like the entry point of the program, right? And that's just sort of like the file that the runtime would look for when you sort of trying to run the file like as a program. So in Python, you didn't have to like do any of this. You can think of it all as it was basically like abstracted away from you. But with Java, we sort of, you can think of it as a little bit more of a lower level language than Python, right? So public static void also. So this main method is actually just a method, and all methods actually has a return type. I'll also be speaking a bit about methods later. So yeah, let's just get to it. It's also something that you have to add inside this brackets, and this brackets is also like, if you guys would recall, the brackets is normally just telling you that this is a method, and then we in Java, so you can think of this curly braces as sort of a replacement for indentation, right? So if this, if this is inside this curly braces, this entire main method, you can think of it as belonging to this class. And if this was Python, you might have indented it. And you can see that even in Java, I'm still following that indentation. And the reason for that is just because it makes the structure of the program more clear. And yeah, the last thing that you have to add here is a string. I'll speak also a little bit about data types. Don't worry about that. String and args. This is just sort of like, how can I say, arguments that you can also apply when you are running the program. But yeah, most of the time you won't ever be using it. But this is just saying that you can also run it with string arguments as well. But we won't be doing that really. So yeah, basically this file, what I'll be doing for now, just like a simple demonstration, because this is at the entry point of the program. And I'll just want to print hello world for now. That's like basically the starting point of any like new language, like when you're starting out. So system.out dot print. I'll also explain this. Let's see. I'll say hello world. Right. And this is also like another thing that you can think of as so in Java, we use like a lot of dots also like for objects. Like if you guys would remember the dot notation, you also get like a square bracket notation, but basically saying that we are going to write hello world to the standard output. So system.out.print, system is like some base object or root object dot out, that's like an output stream, and print is just the method that we're calling. And what this is expected to do is to print hello world to the console basically, because in our case that would be the standard output. So if I press this run button, because I'm in REPL, I wouldn't have to like go the route of compiling it separately. I can just press the run button, and you can see in our console we have hello world. And yeah, you can you guys can also memorize this main method, or just like sort of the syntax of this main method. It will always look the same, really. And yeah, I think that's basically our first Java program, right? Next on the agenda is types. So when I say types, I'll also be referring to variables, obviously, because the variables are like also the containers for the types. And you can see we had one variable here, but this one was actually an array, but we won't be using that one. We'll just start off with our own variables. So in Python, you had like how can I say, you could just think of a variable name, like I'll call it hello in our case. And you can assign it a variable. And in Java, we also have like some data types. Okay, so I'll uh, speak a bit about these data types here. You can see on your screen. So there is sort of like two different types of data types also in Java. The first one is primitives, and the second one is objects. So for primitives, we have int, double, char, and boolean. So this is sort of like in Python, you would just normally assign data to the variable using the variable name. In Java, you have to explicitly define the data type, right? So that's not also all of the primitives. There's also like a few other primitives as well. But that sort of aligns with number one, where we are just define like different types of ints. So you also get like short, long, and byte, but you won't really be worrying about that. That's just more, it's just sort of like a different data type that sort of occupies like a different amount of storage. So int will sort of, how can I say, it's sort of like a mid-range variable, like it would only occupy like a certain range. You also get like long, like say for instance, you want the variable to account for like larger digits, like say for instance the distance between the Earth to the Sun in millimeters or something. So yeah, that's we won't really be worrying about that for now. So int is just basically our integer data type. We have double also, and double is our floating point data type. Char is a single character, which could be basically any character on your keyboard, but it's all represented by the char data type. And we also have boolean, which is once again true or false. So that covers basically the primitives. When it comes to objects, like the object data type, we have a string, which is sort of like sort of one of the most important objects that it will ever use. And a string is basically a sequence of characters. Think of number three primitives, the char, but a string is just a sequence of that. Uh, and also, we can also build custom objects, and there's also built-in objects like we saw with system, but we won't really be speaking about that right today. So let me just give like a demo of the types. So I'll be declaring. So first of all, I declared an int variable. So to declare an int variable in Python, you just have to say num equals 120, and that would be it. Okay, so another thing about Java, every statement always needs to end with a semicolon, right? Unless it's a block level statement. I'll also be discussing blocks a bit later, but a block is basically like this curly braces that we're seeing here. So they don't need semicolons, but normal variables, like when it's a statement that like you are assigning a variable, this will need a semicolon in Java, like always. So if you ran this like without a semicolon, you would get like an error. So you should see the, yeah, it even tells you at line 10. So that's like the nice thing about Java. We have like nice error messages that's sort of pretty descriptive. So it's telling us on line 10, there's an error. We are missing our semicolon, right? And if you see like that sort of error when you are running your program, yeah, it's pretty simple and self-explanatory, really. So once again, going back to Java and the data types, to declare an integer variable, we have to use the int keyword. So the int keyword is also like a reserved keyword, so you can't really define like that just means that you can't define like a method or a variable with that name, right? So you can't say int. That's not going to work out. So if you're using like a nice text editor also, or like an IDE, you'll also see like these nice red lines also. That's pretty like how can I say, indicative that this is an error, and if you hover over it, it's most likely that they'll tell you invalid variable declarator ID. Yeah. So I'll just assign that to num again, and this is equivalent to like a normal variable declaration in Python. And if I go to the other data type, let's see, we had int, we can create like a Boolean variable maybe. So in Java, it's all lowercase for the primitives. That's sort of like a naming convention that we follow. So if you see anything uppercase, you can most likely assume that it's one of the object types, like for instance system here, and also the classes are also uppercase by convention. So Boolean, I'll call this is even, and I'll assign it to, you can assign it to true or false. I'll just say false for now. So yeah, that's the Boolean variable. You also get char. So char is a single character. I'll call it, just think of a name for a character. I'll call it uh, first letter. Right. Uh, so another thing that you guys would be noticing is I use a camel case notation for as the naming convention. That's just basically like saying that you start off with a lowercase letter, and every subsequent letter after that is uppercase, right? So for all variables, you'd always follow the camel case notation. So for the char variable, you can think of it as similar to a string, but as a single character. And the difference is you have to use single quotes for this. So this isn't equivalent to this. So that's sort of like a difference that you guys would have to see there. I'll call the first letter R, or okay, make it A, first letter of the alphabet, right? And yeah, that's basically it for char. Really, as can be like any character, like a exclamation mark, anything really. So right, we're missing one more primitive type, and that would be, let's see, again, we are missing double, right? And double is basically just a variable. Also, you can call it count or num money left. I'll say that, or num money left in account. What? Think of it. Okay, I'll call it price. Here we go. And assign this to variable, and I'll say something like 120 again, but the difference is, yeah, you need a decimal point after that. And there we go. So that's basically it for double, really. And double is sort of also like a 64-bit variable, so you can think of it as one of the variables that can hold like pretty large numbers, and a lot of digits after the decimal as well. And it's also like one of the more precise variables. That's also like another thing when I spoke about int earlier, and I spoke about different variables. The different variables like short, for instance, and byte and long, they would all also have like different precision, right? So you also get like the float variable in Java as well, but the float wouldn't be like as precise. So I recommend using double unless you know that you don't need precise calculations in the form of the decimals. Yeah, so that's basically it. You can basically also print out this variable. So num really let's get some more print statements here. So this is the one method that you can use to print. You also get a different method called print line. Yeah. So instead of saying print, you just say print ln, and that will just print on a different line every time. So I'll just be printing all of these variables to the console. So is even first letter. You can see we even have some green lines here saying that the variable is never used. So until you use it, you'll also get that message for sort of like a warning, basically. So price. And if I run this, you see, there we go. That's our variables. So I suppose that's basically it for data types. You can also perform like the basic calculations, or how can I say, mathematical operations. Like you can add like variables together. Like you can take price and add it to num. So I'll do that. I'll create a variable called sum. So I'll say sum equals num plus price. And yeah, there's also another thing that you have to note about ints and doubles. You can't when you define the type. This is sort of the type of the result of this expression now. So if you try to assign this to an int, you might get a bit of a problem, because you're actually adding a double to an int here, and basically what that will do is it should either do something like, okay, let's demonstrate that also by logging sum. So if I run sum, there we go. We even get like an error message now saying possible lossy conversion from double to int. And that just means that it will lose precision. So it won't be like actually adding this number to that number, like, and preserving the decimals. It will just be, how can I say, it will either remove the decimals, or it won't know what to do with the decimals. So that has to be of type double in the first place. And that would mean that it will get the result of that expression. So that is 240 point. Yeah, there we go. Yeah, so I suppose that's basically it for types. So moving on. There's also something in Java, like I mentioned before, scope and access. So that's basically what I'll be covering today. Here by scope and access, a Java class can contain 3 types of variables. And the first one would be, suppose, local variables. You get member variables, and you get parameter variables. So you guys might recognize the word parameter from like methods. So that's like sort of local to methods, or specific to methods only. Member variables is variables that is also called like properties, or there's a few other words for it, but that's more to do with object-oriented programming, and we won't be covering that. So all of these variables that we created now in that previous part with tabs, those are all local variables, and basically let me show you guys something here with scope. So a local variable is a variable that sort of it's part of this block here. So you can see this curly braces here, and these variables are all local variables to this block. So in Java, you can also declare like a block like out of nowhere, and what that would mean is that if you declare a variable inside this block, that would mean, okay, let's declare another int variable. I'll call it int num2 equals 5400. It's like really random. And if you try to access num2 outside of the scope of this block, you'll also get the error. So that means that even if you try to declare a variable that was already declared, so basically Java works with sort of like a block scope, or what you call lexical scoping, and that is if you try to use so say for instance I try to console.log num here all the way in here num, that would actually refer to that num there outside of this block, right? And so the difference now is if I declared a variable num inside here as well. So I'll say num equals just 2. So now what this will do is it should either, how can I say, give you like an error message when you run it. So let's run this as well. Variable is already defined. So that's like another thing about Java. You can't like redeclare variable using the same identifier. So you can only reassign the variable. So if I say num equals 2, what this does is it takes that variable and reassigns it. But say for instance you're outside of the block, so all of this code will sort of execute sequentially, and if I try to print the value of num outside of the block, it will still print out basically, yeah, there we go, 2. So that was the first time we printed it out. It's 2, it's 2, it's 2. Doesn't matter where you print it out. That is reassigning the variable. So there we go. That's basically it for blocks, and we'll sort of be using blocks in conjunction with methods as well. You can see we used already on the class and the main method. So yeah, that's basically it for block scoping, really. Okay, so let me just give like a brief example of like a member variable as well. So a member variable or like an instance variable is just a variable that is defined at the class level. So you can define a variable all the way up here. You can say int what has not been used here. Let's say double price of bread equals 200. What price of bread is that? 16. Right. So this variable is sort of, how can I say it? It's also like part of a different scope. It's part of the class. That means that you can access this variable anywhere inside the main method, really. But we won't really have to be working with global variables or like instance variables in this case. So it's like a bad practice to declare the variable all the way up there, unless you have like a specific goal in terms of object-oriented programming. So that's not really required here. And another thing that I also want to mention here is also access modifiers. So you get 4 access modifiers. It's public, default, protected, and private. So public is accessible basically anywhere in the project. So we can see in our example there, we created variables. We made our class public and we made the main method public. So that just means that it's accessible anywhere. And yeah, there we go. Default. So I'll also speak about default a bit. Default is actually only accessible inside the package. So if you're creating like maybe a project with Eclipse or something like that, or like a different IDE, you might be working with packages as well. But I won't be like speaking like a lot about packages here really. You also get like the protected access modifier, and that just means that it's accessible anyway, sort of inside that same directory, but also it's also accessible by anything that it inherits from. So if something like a subclass inherits from that class, then that class will also have access to that variable by default. And lastly, private is only accessible inside that class itself. And if you try to use the variable outside of that class, you'd get an error or the variable isn't accessible. So let me just give like an example here. So there we go. So for public, we can see that this class here is public. And if I created like another Java file and try to access maybe this instance variable here, or try to sort of import like backwards from that file inside here, it's public, so it's accessible. But for private, if I try to make like a method private, so I'll also do like a little bit of a method here. I'll get like a basic method called sum, just to sort of demonstrate that here. So I'll actually give it the private access modifier now. And now once you see that private keyword, it's accessible only inside this class. So I'll get like another method. We can see we have this method here, public. I'll have to make it static also, because static also belongs to the class. So if I try to like use like, so you use static basically anytime you don't want it to belong to a specific object of this class. So I won't be using like OOP to create an instance of main really. So this method is basically like a standalone method. So another thing that also applies to all methods would be the return type. You can see here we had void here. That just means that this method is returning nothing. But maybe in our case, we want to return an actual integer variable. So you have to define that as int, and I'll call this method basically sum. But the purpose of this method will be just to add up two numbers together. So the brackets also, that's also like indicative of this is the bracket, this is the method definition, and the curly braces once again. And now this method now would also have its own scope as well. So any variables you declare inside this method, is local to this method and it can't be accessed anywhere outside. So I'll be using also parameters here. It was another part of like, how can I say, like a variable type. So this is like the local variable. We had our instance variable here, and a parameter is basically what you define for the method. So I'll call this int num1 and int num2. And the purpose of this method is basically to sort of call this method with two arguments, and that will be an int and an int. And what this method will do is it will return. So if you use the return keyword also, it's the same like in Python. It will just return just jumps out of the method and returns the value. So if I say return 1, this method, no matter what you call it with any numbers, this method will just return 1. So I can basically add num1 and num2 together. And what this method, now basically we have like a fully functioning method. This method will basically take in two ints and return the sum of the two ints. So now here you can see here instead of, so that's sort of like another sort of, you can call it a caveat or like something that you have to watch out for in Java. So now you might think that the sum method would apply to any variables like but the problem is, or sort of its advantage later, you will see its advantage. But in our case, if you wanted to now call that sum method, you might think that you can just say sum and call it with two variables. So you can say 1 and 1. Yeah, so this looks right. It's basically supplying two ints, but the problem is now that we are declaring this as double. So we actually have to make this an integer variable, because the result of this is actually an int as defined here by the return type. So that's basically doing the same thing as 1 plus, as saying 1 plus 1, but except we're just using a method to do it. So yeah, I think I've spoken also like enough about access modifiers, but now basically for private here, this method can't be accessed if you had like a different class. So say for instance I create like a class here, I'll call it another class following the same bracket notation here. And now say for instance I have like a different method here or something that is dependent on a sum method. I can't use this sum method because it's only accessible inside here. So yeah, that's basically it for access modifiers. And access modifiers is basically anything before like the normal variable declaration. So you can actually declare a variable without any of those. You can say in sum. That will basically do the same thing. So I'll just basically copy that and paste it. So now, actually this one now would have default access. So default access is defined when you don't define any access modifier like public or private or protected. So this would be accessible in anywhere inside the package. So yeah, that's basically it for access modifiers, I think. I don't think we have to cover protected because that's like a really special case and that's to do with object-oriented programming. So we won't be really focusing on that. So that's it for scope and access. I actually sort of covered like one method here, but I'll also be speaking like a little bit about control structures and methods. So a control structure is something that you can use sort of to control the ebb and flow of the project or sort of the program, actually, not project, the program. So if statements or conditional statements qualifies as that, and also loops. So that's something that any programming language should have. So if statements or like conditional statements, you also get like different forms of it in Java. You get like the switch case method or switch case construct, really, you can call it a construct. And what the purpose of this is basically to evaluate or sort of do something based on a condition. So the default, this is sort of the default syntax for an if statement here. But we actually are required to have these two brackets here. And anything between these brackets needs to evaluate to a Boolean expression, actually, which was one of our dot types, right? So you can actually say if true. That's sort of like the base form of it. But this is more useful when you actually have comparisons. So what I can do here is I can say if num1, or basically taking that variable here, if num is equal to, use the double equal sign for comparisons, if num is equal to 120, then now anything inside this block, once again we have like another example of a block like we had on our method and our class, and whatever you say here, I'll say I'll take a print statement and I'll just say that this is correct. This is correct. So now, yeah, that's basically the syntax for if statements or conditional statements in Java. You can also have like else's, and if you say else, oh, I wasn't sharing my screen. My word, sorry for that, guys. So yeah, this is basically the syntax for a conditional statement or if else statement. So you can see here that we have brackets for every sort of statement here. So as I'm saying, if num is equal to 120, right? And you can see that it is going to be true. But yeah, that's the base form of this is if true. And what you can see here is that this would always execute because true always evaluates to true. So yeah, without the else statement, you can see that this would actually execute. But say, for instance, it was something more difficult that you can say if num is greater than 100. There we go. So this is more like sort of a condition. Now, this could execute or it could sort of skip entirely. So else is basically now when this expression evaluates to false. So basically, whatever you do here, it's almost likely that you do the converse operation here. So I'd probably say here this is incorrect. And if I run that, we're still having that problem with some. Could that be saying a static method? Oh yeah, we actually need static because we're actually calling it inside the method that is static. So this method also has to be static. Therefore, so if I run this now, and you can see here it's saying this is correct. So yeah, that's basically it for if statements. You can also, instead of saying else, you can also add another else if with a different condition. So you can say else if num is greater than 120. Then it would say this is greater, right? What this is basically doing is it's still the same else statement. It's not like anything special here. It's not like a new construct, but we're just basically combining the else statement with another if statement, which is the same, which is similar to this one here. So you can also like nest multiple statements. You can else if, and oftentimes the last one is else, and the else is basically if none of these was ever true, and that's when you just probably print out. So in your program, this is often the time when none of the inputs of the program or from the user is like anything valid, right? So, so I'll just say this is invalid input now, right? So that you can see based on this expression, none of this would actually ever get to execute because num is already 120 and 120 evaluates to greater than 100. So none of them ever gets really executed like in terms of the conditionals. And that's sort of like the difference between if you just made this their own if statements, right? So that goes there. And yeah, basically just remove that for now. And now all of these statements would sort of try to evaluate it regardless of if this one is true. So this will print this is correct, this is greater, then it will print this is greater again. And suppose that's it for the if statements. Another way to sort of control the flow of your program is to use loops or iteration. The standard way for the for loop or is to use a for loop or a while loop. So the while loop is sort of similar to the if statement. It takes that is also like a curly braces, and that means that this is another block, and that means that it has its own scope once again. And the expression that it takes here also has to evaluate to true or false. Now take note that you shouldn't actually run code like this, because this is basically like an infinite loop. This is saying while true. And normally this is like a condition that has a chance to be false. So I'll say while num is greater than 120. 120 is pretty near, it's already 120. This might never actually execute. So that's like another thing that you have to also check with your while loops that you use. Is this condition ever going to execute? Otherwise, the output is going to look like a little bit weird. So what I'll do inside this while loop is, all I'll do is I'll just print. I think I can get rid of some of this noise here. I'll just put that under. And we're referring to number, and this will print while num is greater than 140. But the problem with this is it's still an infinite loop, because there's no chance of not being 140 inside this block. So this is oftentimes like inside the block, or by some other method that you call, you have to actually make num be greater than 140 at some point for this to ever exit. Otherwise, it will just be like an infinite loop, and it will actually like crash your virtual environment, or probably maybe give some sort of error or exception. I won't tempt fate here by doing that. So what you can do here is you can say num, just like a basic increment statement. You can actually say num plus plus, and that's the syntax for just adding 1 to num, and this will happen as long as num is greater than 140. So if I run this, oh, we can see something didn't happen. System out at print line num, all num is greater than 140. Okay, num plus plus. That's not actually executing the current code. Okay, so this is like the problem that you encounter with REPLs, I think, at times. I'll just copy and paste this and put this in a new REPL. So just put this in a different REPL. Like sometimes it just doesn't, like, how can I say, ever save the code. So I'll just get like a new one. I'll call this Java Essentials. Oh, this is more like a crash course into Java, right? So there we go. If I run this now, it should run the current code. We have something wrong with this while statement. Num is greater than 140. Oh, great. That's my problem. That was pretty simple actually. Num actually never becomes greater than 120. So what happened actually in the previous example also, it wasn't actually that problem. Num should actually run until it becomes 140. And what we were doing was we were adding 1 to it every time. But my operator was wrong. So if I'm saying actually while num is smaller than 140, it initially is smaller. So that's how I know that it will run at least once. And if I run this now, yeah, that's basically what I was going for before. So I'm going to print out all the numbers until 140. And you can also use the sort of like a compound operator here. You can say greater than or equal to for that. So that was basically like another example of an infinite loop. So I advise you like to not get caught out with this. If I said now greater than this looks right, you think you want it to run until it's greater, but the thing is it's still smaller. It will never be greater. So yeah, just watch out for that in the while loops. So while loops are usually used when you don't know exactly the amount of iterations that is going on. In our case, it was 20 iterations probably, or 19 iterations, but it's not always possible to know that. So right, I'll be diving into the syntax for the for loop. So for the for loop, use the for keyword again. It's again this, how can I say, round braces. And the thing inside here is also supposed to have 2 colons. And what this 2 colons basically represents is like between this, you'd have like statements. And most of the time, like in the middle, that's where you have like a conditional statement. So you can say here, say for instance, never mind. Let's start actually from the beginning. So the first part that you do for the for loop is to assign a variable. So you can say int I equals 0. That's normally like the starting value of this variable, and this variable will be used to control this entire loop actually. So the next part here in the middle that you do is, this is the conditional statement. So similar to the while loop statement actually, this expression has to evaluate to a boolean. So if you say true, you have another infinite loop, but most of the time you actually run while I is smaller than something. So in our case, I'll just say 20. Once again, you can also use greater than or equal to. And the last statement is the increment statement, just to actually make this actually catch up to that. So if I say I plus plus here, then yeah, so the value of I will start out as 0. Add another print statement in there, and I'll call that I. So yeah, that's basically it. You can see it started out at 0 and it ended off as 20. Right, there we go. So yeah, that's basically like the standard syntax for the for loop. Obviously, you can manipulate these variables, or you can call this variable anything you want to. But I suppose that's enough for the iteration part of it. You can also see like an example of the method here. We just created the method here and we called it to actually give us the sum. So this basically has that abstraction sort of. So behind the scenes, it's just adding up. So looks like a simple abstraction, but oftentimes like this operations inside here is complicated, and you don't actually want to have to look at that just to see the result of the operation. So yeah, that's basically it for the control structures and methods. Okay, so next we're going to cover a little bit of file IO. Wow. Okay, so this one is like a little bit complicated. I think I'll skip that for now due to time, but that's also like another thing from like Python that you might recognize. You can also use the scanner to read like from a text file as well. So there's like multiple ways to like input things as well. So I'll just skip file IO for now and cross that bridge maybe in another tutorial. So yeah, there we go. So that's basically it for now. So to round everything off, Java is a statically typed multi-purpose cross-platform programming language, which has quite diverse applications, or like quite the diverse applications in various industries. We saw basically like statically typed or strong type, sometimes you call it, like it's like a different concept, but it basically means that you define your types actually instead of just the runtime or the compiler deciding what is the type of the variable based on the data, right? So yeah, that's basically it. So what I'm saying here also is, while Java might seem sort of like a little bit strict in terms of like syntax, those all of those syntax restrictions actually help you write like a better program. So it's not like restrictions for the sake of restrictions. It's sort of to guard you against yourself, sort of, because developers can sometimes be their own worst enemies and write code in a sort of bad manner or like following bad practices. But essentially, Java has like lots of safeguards against that, and it will allow you to write pretty safe code. And also another advantage is that the compiler gives you like pretty useful messages, like as you've seen there when I omitted the semicolon. I told you exactly what line and that you have to add a semicolon. Yeah, so I suppose that's basically it for now. So any questions? Now's the time for any questions.